In this video, I'll be explaining question 1 of homework 11. The question states that the stochastic process xt is real, white, and stationary with autocorrelation given as Rx6 of tau and spectral power spectral density given as Sx6 of omega, and we need to show that the autocorrelation is real and even, and power spectral density is even and non-negative. So uh, since we are given that x of t is real, white, and stationary, so the autocorrelation is a function of tau, which is uh, the time difference of t and t plus tau. So autocorrelation Rx6 of tau is equal to expectation of x t plus tau times x t, and in the next step we can write it as Rx of t plus tau and t, since it is tau is difference of t plus tau and t, and this is basically same as expectation of xt plus tau and xt. So expectation can also be written as expectation of xt and times xt plus tau. We are just swapping the values of x, so it will be xt times xt plus tau, and this thing can be written as t minus tau, or autocorrelation of t plus tau, which is basically Rx6 of minus tau, because the difference of t minus tau, t minus t plus tau is basically minus tau. So yeah, the final thing will be Rx6 of tau is equal to Rx6 of minus tau, and this is what is the definition of an even function. And so yeah, for the first part we have to show that it is real and even. So since we know that the expectation of real values will be real, so Rx6 of tau is also real and even, because we have proven that Rx6 of tau is Rx6 of minus tau. For the second part, we need to show that the power spectral density function is even and non-negative. So power spectral density can be written as integral of Rx6 of tau e raised to power minus j omega t dt, j omega tau d tau, where the limits will range from minus infinity to infinity, and so e raised to power j omega tau can be written as cos omega tau plus sin omega tau, but since here is a minus sign, so we'll write it as cos omega tau minus sin omega tau. And Rx6 of tau is an even function, this is an odd function, this whole will be an odd function, as multiplication of odd and even function is an odd function, so this whole term will be, when integrated among the symmetric limits, it will be 0. Similarly, for the first term, when we integrate an even function, it will be twice the limit from basically 0 to infinity. Yeah, so, and if we replace omega with minus omega, basically we are saying that the sx of tau omega is equal to minus omega. So that, and this is true actually, because we know that cos is an even function, so cos omega t will be equal to cos of minus omega t. So these two are basically same, which means that the power spectral density uh, as a function of omega is equal to power spectral density as a function of minus omega. So that means this is an even function. So we have proven that. And yeah, for the non-negative thing, we know that the integral of non-negative, uh, these are non-negative values, and when integrated over positive value, this will give us non-negative values. And yeah, the area of power spectral density in interval is non-negative. Therefore, yeah, so that is all for question 1 for homework 11.